All right. That'll work. Now it's perfect. It'll work for Jonathan. So now everybody have the midterm review, or do you want another copy?
I have a midterm review.
Right. Yeah. So I'm gonna go through just very briefly 1.8 or 1.9, and then we can start going through midterm review. So 1.9 session 1.9 is radical equation. So remember that we were talking about stuff like, for example, radical 100 is positive and negative 10. That's basically what we talked about before. So now the difference is we're gonna put this into an equation. So, example. Let's just say that radical x equals 10. Let's just make it like, this is a simple version of the problem. And well, how do we solve this? Well, the first thing to look at is, we do not want the radical. We want to somehow get rid of it. So what we're gonna do is, we will apply the opposite of a radical. And the opposite to a radical is the square. So I will apply square on the left and square on the right. And what happens is, square, radical, they destroy each other. So all you get is x equals 10 squared is going to be 100. And that's it. Just leave it like that. So that's also there. And keep in mind that it doesn't matter what kind of radical you get. So for example, if you have the cubic root of x equals, let's just say it's going to be 2, for example. You just have to apply the same thing corresponding to the degree of the root. This is a square root, so use the square. This is a cubic root, so therefore you would just apply the exponent of 3. Just like that. So if that's a 4, you will do 4. If that's a 10, you do 10. So on the left-hand side, that's just x. 2 to the third power is 8. And that's it. This one is pretty straightforward. So the issue is, what if you got something that's a little bit more tricky? So for example, let's say you got something like the fourth root of 5x minus 7 equals 2. That's what you're like, wait a minute. There's a lot of stuff going on inside the radical, right? Well, that's okay because you apply the same principle. You have a fourth root this time, and we want to get rid of it. So let me rewrite this thing. The fourth root of 5x minus 7 equals 2. I will just go ahead and apply the fourth power on the left-hand side and the right-hand side. You always do the same power. And on the left-hand side, the radical and the power just go away. So that's 5x minus 7. 2 to the 4 power is what? 2 times 2 times 2 times 2, that's 16. So you see, just like that. So no trick. 4 power on both sides and just work it out. I'll go ahead and do plus 7. And I get 5x equals 23. Then you divide by 5, right? So that'll be x. You can write 23 over 5. On a midterm, it doesn't matter. If you give me a decimal number, I'll take it. Decimal, that's 4.6. Fraction is 23 over 5. Doesn't matter. Either way, I'll accept it. And there will be a problem like this, I believe in Richard. So okay, well, this one isn't too bad. How about this guy? this next guy is gonna be the cubic root of 6y squared plus 15y. The cubic root of 4y squared plus 8. So this guy look more terrible because it's just got a lot of stuff going on. And I will rewrite the problem one more time, just so that you see what I would do. I have the cubic root on the left and the cubic root on the right. The game is about getting rid of the radical. So if I see the cubic root, okay, apply to the third power. Only this time, this is nice because it can clean up both the left-hand side and the right-hand side. Right, you simultaneously destroy this guy and this guy at the same time. So you get 6y squared plus 15y equals 4y squared plus 8. And you just gotta work it out from here, right? And this was a little bit tricky because when you move your stuff to the left, you'll see that like this. Minus 8. Minus 8. So that will become a 2y squared plus 15y minus 8 equals 0. And this one's more tricky because once you get to the end over here, you have to use the quadratic formula. That's it. A, B, and C. And we can, we can work it out, we can put into the formula and get it done. But you know what? I'm just gonna kind of just leave it up in here for now. And so in this case, A is 2, B is 15, C is -8. Just put that into the quadratic formula. And the answer is going to be let me just kind of write this down. So that will be -15 plus or minus 15 squared minus 4 AC over 2A. Once you clean it all up, once you put in, you can either use the calculator or, just work it out just step by step and all that, right? And you will get the answer are going to be 1/2 and -8. So if you work it out, you'll get those two answers. So these guys are not too bad. It's just like the quadratic formula. That's more tricky, right? You gotta, plug into the formula. But now let me show you this one. This guy's gonna be a little bit crazy because I have a radical on the left, but I got some stuff that's got stuck in the middle, right? At +9. My first order of thing is I want my radical to be by itself. So bring the 9 to the other side, -9. And that's right. So you get radical 2x plus 13 equals x, that's -1, right? like that. I like to get the radical by itself, and then I can work on it. And you guys recall, every single time before, right, to get rid of radical, okay, we got a square root, take a square. So take a second power. The only issue is on the right-hand side, you gotta square these two. And don't be like, okay, well that's x squared and 1 squared. Can't do that. You have to do this. You have to do on the left-hand side, that will just be 2x plus 13. On the right-hand side, this guy right here is x minus 1 times x minus 1. Because when you square, you multiply by itself, right? This becomes a FOIL problem. You will have to do x times x times minus 1, negative 1 times x, and negative 1 times negative 1. That's the pitfall for this problem. A lot of people, they immediately think, oh, when you square this, that will be x squared minus 1 squared. Doesn't work like that. You gotta do the whole formula. Well, let's work it out. Let's do the formula. So that's 2x plus 13. X times x is x squared. And then the outside term is minus 1x. The inside term is also minus 1x. The last term, negative 1 times negative 1 is plus 1, right? So now let's clean it up. So that will be 2x plus 13 equals square minus 2x plus 1. But we're almost there, we're getting there. So now we gotta bring the 2x and the 13. Remember, when you have x squared and x at the same time, you want one side to be 0. Bring everybody to one side. I'll bring everybody to the right hand side. So I will do minus 2x, minus 2x, minus 13, and minus 13. Then I will see what that becomes. So on the left hand side, that's 0, right? And that will be x squared minus 4x minus 12. So do you see that all these problems in goes back to the original guys, which is the quadratic formula thing. Like in this case, you don't have to do quadratic formula because, let me write this down here. You can do factoring. So for this guy here, that's 0 equals x squared minus 4x minus 12. Well, for 12, you recognize that this is either 1 times 12, 2 times 6, or 3 times 4. Then you just kind of sit down and think about which pair will give you an answer 4. Well, the only one pair that will work will be the 2 and 6, right? And to get minus 4, that will be what? Plus 2, minus 6, right like this, right? So this guy is just 0, and that's x plus 2, x minus 6. And that's using stuff we learned from earlier in the units. And once you have 0 and you have everybody factorials, remember you can break it in 2, right? This guy is broken to x plus 2 equals 0 and x minus 6 equals 0, which of course the answer will be negative 2 and positive 6, right? So on the midterm exam, let's say you give me those 2 answers, I'll be like, you know what? I'll probably just give full credit. But I might take a point on it. It all depends. And the reason why is because you have to check your answers. Remember when we did the fraction thing? So remember when we have fractions, what we mentioned it was, if you have 1 over x, that means x cannot be 0, because the bottom cannot be 0. Well, what happens when we have radical x? Now, I know that we learned imaginary number, but when you do equations right now, we're not using imaginary number at all. We just say, simply, x has to be bigger than or equal to 0. X cannot be negative. If x is negative, you get imaginary. We don't want to deal with that right now. So now, looking at your answers, right? If you're plus 6 in here, not a problem, right? 2 times 6 is 12. So let's check our answers. Let's check. So x equals -2 and x equals 6. Let's check to see if they're correct. You should always check the answer anyway. I just don't do it because I'm lazy. But let's put -2. So you put -2 in the original guy, you get radical. 2 times -2 is -4, right? So that's -4 plus 13 plus 9 equals -2 plus 8. And that'll be radical, that's 9 plus 9. Like this. Radical 9 is 3, right? And that's 6. You see the problem here? You see when we plug it in to -2 here? What happened is that becomes a 12 equals 6. That's a no-go. And you're like, why does that happen? Because what the radical does here is they are taking the negative into consideration. We are saying we don't want to deal with that. We just want to do the positive. That's why this doesn't work. So this one's a no-go. Let's look at 6 and see what happens. Well, let's plug in 6, so that's radical. 2 times 6 is 12, so that's 12 plus 13. And then plus 9 equals 6 plus 18. And 12 plus 13 is 25, right? So that's radical 25 plus 9, and that's 14 over here, right? Radical 25 is 5, so that's 5 plus 9 equals 14. 14 is indeed equal to 14. Check. So this guy only has one answer, and the solution is 6, not -2. But on the midterm, if you did all the work and then you just mess up with the last one, man, I feel sympathetic towards you because there's a lot of work you put in. So I might just let it go. How about this? If you made a mistake like this one time, I take a point off. And if you make the same mistake, I'm just going to ignore it. All right. So you only get maximum, you will lose 1 point, right? But I really want people to check the answer, and the reason is your answer could be wrong. Like you might just actually did something wrong in your problems, and it's always good to check the answer before you move on. But are you guys okay with this one? You can bet this one will be on the midterm. One of the midterm problems. I want to do one more problem that look like this from the lesson, but it will not be on the midterm. The next one's going to be hard. So could I erase here yet? So what about on the left hand side? You got it? Okay, I just want to make sure. It's a lot of writing. So now for the last problem, it's something like this. Now this guy is almost guaranteed you will have to work to get the answer. Because right from the start, you recognize that we have 2 radicals. And that's always going to be more difficult. But before we do that, I want to ask you something. If I say I have radical y times radical y, Do you guys remember that that's just y? Remember radical or something comes radical or something? It's just by itself. Because this guy would just be radical y squared, right? Which is just y, right? So what that means is if I do radical y plus 1 times radical y plus 1, it will just be y plus 1. So in our case, if you have 7y plus 1 times radical 7y plus 1, it will just be 7y plus 1. This is always going to be true. Radical of something times radical of the same thing, you just lose the radical. That's all. And that's going to be important for this thing. So the first thing we're going to do is understand that we are trying to get rid of the radicals. So I would apply square on both sides. I'll square the left and the right. Now the left hand side is easy because the left hand side would just be, you just lose the radical. That's 9y plus 4. The right hand side, however, is going to be tricky. Now again, some people say, hey, does the square go here so the radical is gone and then 1 squared is 1? Can't do that because again, this guy will become a FOIL problem. It's just going to be a massive one. It's going to be a massive FOIL problem. But that's okay. That's why I wrote the little trick on the right side of the corner. So we got to do the FOIL. We got to do the FOIL. And you know, well, how do I do the FOIL right here? Well, treat the first guy as just x or y, whatever. This guy times this guy. Well, we already said what's going to be. We said this radical times the same radical. All you're going to get is a 7y plus 1. That's the first terms. The first guy times the first guy gives you everything inside the radical, and that's it. That's what we said on the right side of the corner. And now look at this outside term. That will be plus 1 times radical 7y plus 1. And that's right. Inside term would be another 1 times radical 7y plus 1. Last term, 1 times 1 is 1. And now all the attention is probably on here, the middle guys, right? I want you guys to look at this and be like, and pay attention to this thing. Remember, we said radical whatever, that's just a like term. Treat that as an x, right? This is like 1x plus 1x. They are like terms. You'll get 2 of these. So let me rewrite this. 9y plus 4 equals 7y plus 1 plus 2. Radical 7y plus 1, right? Just put those two together. And you have a plus 1 in the end. So you just put the like terms together. And now we're going to clean up everything else. I will move everybody to the left hand side except for the radical. I will isolate the second letter, the radical. We got rid of the first one, we're going to get rid of the second one. So I will do minus 7y, right? Minus 7y. Minus 1, minus 1. And I have another one, right? Minus 1. So that will be 2y. And plus 4 minus 2 is plus 2. Equals 2 radical 7y plus 1. That is. So now this crazy problem has become a little bit more manageable, right? A little bit more. So let me bring this over here to the, I'm gonna finish the problem here. 2y, let me just, let me put on the top. 2y plus 2 equals 2 radical 7y plus 1. At this point, I will do the same trick as what we did before. I'll go ahead and apply square on both sides. Now some people ask me, hey, what about the 2 over here? Don't you have to move it? You can if you want to, doesn't really matter. In multiplication, is no problem. Now, you can divide the 2 over on the other side, that's fine, you don't have to. But when you square a product, when you multiply, so this is a multiplication, right? You just square it over. So that's no problem. Over here though, this becomes a foil problem. So on the left-hand side, that's 2y plus 2 times 2y plus 2. On the right-hand side, 2 squared is 4. And then the square destroy this radical. So that will just be 7y plus 1. And this one's definitely difficult now, but again, remember, it's not on the midterm exam. This is way too hard to be on. It's on the homework, and I'm supposed to go over that problem. So once again, on the left-hand side, FOIL. When you do FOIL, there'll be 4y squared, that first term, right? Last term, or the outside terms is 4y. Inside term is 4y. Last term is 4, right? And that's 28, y plus 4, once you distribute. Well, we're getting close. Let's see what happens. That's 4y squared plus 8y plus 4. Right, I combine those 2 terms, and that's 28, y plus 4. And now notice something. I am now the radicals are all gone. So I'm gonna move everybody to the left-hand side. Minus 28y, right? Minus 4. So that becomes 4y squared minus 20y, that's gone, equals 0. See how that's a lot cleaner than before now? It's getting easier as we go. It's a lot of work, right? Once you get to that point, look at this. This is not a quadratic. I mean, it's not a 3-term problems anymore, just 2. You can simply look at what can you factor out of these guys. I can factor 4. Like 4 in the middle of both, right? And a y, right? 4 goes in there, gone. Y squared take away y is 1, right? Minus 20 divided by 4 is 5. Y divided by y, that's gone. So you basically get these 2 things. And then you set both equal to 0, right? 4y equals 0, y minus 5 equals 0. You can divide by 4, that's y equals 0. And then plus 5, that's 5. So you have 2 answers, 0 and 5. And you can check the answers. It's gonna be right. You can check it out. Right? But I already did. I already checked the answers. Both answers are correct. And now I'll be honest. When I check, I don't write down everything. Here's how I check my answer. Y is 0. Okay. If that's 0, that's gone. Radical 4 is 2, right? If that's 0, that's gone. Radical 1 is 1. 1 plus 1 is 2. So 2 equals 2. That's how I know 0 will work. And what about 5? 9 times 5 is 45, right? 45 plus 4 is 49. Radical 49 is 7. That's 35 plus 1 is 36. Radical 36 is 6. 6 plus 1 is 7. So I can do it in my head now, you know what I'm saying? I just mentally work it out. You don't have to do that now, you can just do by hand. But this one is probably as high as it can go for 1.9. And again, not on the midterm, not on the final, it's in the homework, but if you run the problem home, just say if you have that problem. And now we can go into the midterm. What do you guys think about this 1.9? This last one is a little bit tougher, but what about the one before? You guys are confident about it? Let me see now. Since you all have to